Okay, this is problem 8.4 in the workbook, and this is a person who buys delphiniums, that's D, and hollyhocks, and she has an indifference curve map that consists of these red curves, okay, that have the slope of -1, and we would get that by setting h plus d, her utility function, basically equal to some number, solving for d in terms of h, and you'd see that they have the slope of -1. That makes these perfect substitutes. In fact, that's how we got the utility function. It was given that she thought these were perfectly interchangeable. So we could infer the linearity of the indifference curves, and we could write down then the utility function h plus d. We're given initially that the price of a delphinium is $4 and the price of a hollyhock is $5. So with delphiniums on the y-axis and hollyhocks on the x-axis, that means that the slope of the budget is going to be initially -5/4. Okay, so we're looking at the blue budget to start out with. Because the budget is steeper than the indifference curves, we can see that the best she can do for herself is at the northwest corner, that is at point A, up here, right here. That's the highest red indifference curve she can attain, given that the slope of the budget is steeper than the slope of the indifference curve. So we start with an optimal choice at point A. Next, we're supposed to consider what happens if the price of delphiniums falls to $3, okay? So we're going from a price of 4 to a price of 3. That makes the budget even steeper, so we're now on the black budget, okay? This one right here. And this black budget is going to lead us to an optimal choice up here at point B, okay? So in other words, the budget is still steeper than the indifference curve, and the best choice for her is still in the northwest corner, okay? It's worth thinking a little bit about the meanings of these two things, right? The black budget tells us the opportunity cost of a unit of H, how much D we have to give up to get another H. The red curve tells us how much we're willing to give up of D in terms of H. The market says we have to give up more D than we're willing to give up to get another H, and so we're not going to do it. We're going to simply consume all D. Our D consumption, D star, is M over PD, okay? And so because PD has fallen, our D star has risen from point A to point B. So that's basically just the net change in behavior. A to B is the net change that we want to explain in terms of income and substitution effects now. Substitution effect says, well, we should be able to take the new slope, that's the slope of the black budget, right? We should be able to take the slope of the black budget line and impose it over point A. So I'm going to draw this green line here, and that has the new opportunity cost, but we're making point A just affordable. We're compensating in income. In this case, we're taking income away so that A is just affordable. If they faced the green budget, they would still choose point A, right? Because the green budget is steeper than the red indifference curves. So we started at point A. It turns out that point A is also our point S. When we expose them to the new prices but make A just affordable, they choose A again. So there is no change in behavior due to the substitution effect. Now we allow the purchasing power of income to rise, which results in the shift from green budget to black budget, parallel shift outward, and the movement from A to B. So all of this A to B movement is income effect. Okay, let's go on and look at part B in this problem. So we still have delphiniums and hollyhocks, but now we're given an income. We still have the price of hollyhocks as 5, price of delphiniums at 4. We've got red indifference curves with slope of -1. So with the information here, we can sketch the blue budget line into the picture. 120 over 5 is 24, 120 over 4 is 30. So we have the intercepts of the blue budget. I've superimposed a red indifference curve onto the picture so you can see that the best that the consumer can do is point A, which is 0 hollyhocks and 30 delphiniums. So next we're going to allow pH to go to $3 a unit. So pH is actually falling from 5 to 3. If that happens, then the budget is going to rotate out. And we'll hit the axis at 40 now. The slope is -3 force. And we can contemplate then where the red indifference curve is going to lie in relation to that budget. At this point, the indifference curve, which has the slope of -1, is now steeper than the budget, and therefore the best that the consumer can do is at the other corner. Okay, so that should have the slope of -1. It should be steeper than the slope of -3/4, and the optimal point will be right here. So here is our B point, right there. What income would Maud need to afford her old bundle A? That's kind of a tricky question. At bundle A, she's not consuming any hollyhocks, so the change in the price of hollyhocks doesn't affect the income required to afford the original bundle A. So she had $120 in income before, and that's what she needs to afford A after the fact. Now we want to look and see at how much of the change in behavior was due to income effect and how much was due to substitution effect. So what we're going to do with income and substitution effects, of course, is expose the consumer to the new prices, but make sure that the original bundle is still affordable. So we want a budget that has the slope of the new budget, that's -3/4 right here, the black budget, but it runs through point A, okay? And point A was our original choice, so it has to run through point A again. Well, lo and behold, that really is the black budget, okay? So when we look for the budget that runs through point A but has the new slope, it's the actual new budget in this case. And the change in behavior that's associated with that new black budget is the movement from point A to point B, and therefore A to B is all substitution effect. Okay, so the plus 40 on the h-axis, okay, can be said to be the substitution effect. Well, if the entire change in behavior was due to substitution effect, it must be that the income effect is 0, okay, because when we now allow the income to actually change as a result of the new budget, there's no change in behavior. Essentially, that's because there is no subsequent parallel shift in this case, so there is no income effect at all.